Hey, good morning, grade 6. Welcome to a new day. We are going to look at reading and predicting graphs as our next lesson in our math books. And by the end of this lesson, hopefully, and the end of the practice in the workbook, you will be able to read values from broken line graphs and predict what happens outside the range of data points. I'll explain that in a second. And then distinguish between, and this one becomes important on the second part of the practice that you're going to do, is to distinguish between when to use bar graphs and when to use broken line graphs. So here's where we're going to start. We're just going to review reading broken line graphs. And there we see a broken line graph. It shows the cost for the number of books that get purchased. And so over on the right-hand side, it says, well, how much does one book cost? And so we can use this broken line graph. It's pretty easy to see that it's $5. But if you want a little bit extra support, what you can do, let's see if I can get it all the way, I probably can't get it all the way over to the edge here, is you can actually just take your ruler and sort of line it up and say, okay, actually I should do the other one first. I go over to one book and just draw, have it line up a ruler up following at number 1. I can grab my other ruler and sort of do a crosshair where they intersect. And again, we can see then that one book costs $5. Next one says 2 books, so I can slide this ruler. And again, I have 2 rulers here because the rotating feature is kind of a pain. You're probably going to only have 1 ruler, which means you have to kind of rotate it. But I slide it up again, and so 2 books is going to cost $10, and then I can slide it all the way over to 5 books to see that 5 books cost a total of $25. And again, that's indicated in your workbook using the ruler method. It's in that gray box at the top of page 49. It's a thing that you can do to help you out. Now, there's a question here that says, well, how many books can you buy for $20? And that's an interesting question because that number is just a little bit down, and we actually have to go in reverse and say, okay, well, here's $20. And so then I got to slide my ruler over and see, well, $20 will buy me 4 books. So it's kind of like looking at it in reverse. So the first 3 questions ask us along the horizontal axis, and that last question there asks us along the vertical axis. Now, on a broken line graph, the points between data values aren't always possible. In other words, it sometimes means that it is discrete value. Right, so on the last chart, it's not possible to have part of a book, right? You're not going to be able to buy half a book. But what it does do, and this is what it says here, is that it shows us trends and allows us to make predictions outside the range of current data. And so what I mean by that is, let's look at this. This is the same graph. I can move the whole thing up. So it's outside of the... There, it's easier to see. That watermark is in the way. So what this question asks us is how much 6 books would cost. Now, this is a situation where 6 is actually outside the range of data because it only goes up to 5. But what you can do is if you think about this and you could just extend this line further on to get 6 books. So you could draw the 6th value. But if we look at, one book is $5, 2 books are $10, 3 books are $15, hopefully what we start seeing is, well, there's a correlation between the number of books and how much they cost. It seems like each book costs $5. So I just take the number of books and multiply it by 5. So if I want to know how much 6 books costs, I would multiply that by 5. And so I would know then that 6 books are going to cost $30. Even though it's outside the range of data on the graph. And I can, that example, I could say, well, if I want to know how much 10 books cost, well, that's going to be 10 times $5, which means it's going to cost $50. Okay? And so that is a way that we can make predictions about data values outside that aren't on the graph. Okay? Sometimes you should use a bar graph, right? A broken line graph is not always the best choice, but these are the times where a broken line graph is a better choice. So a broken line graph is best when the data on the horizontal axis is continuous. In other words, there's values between the points. if you want to see trends, like if you want to connect the dots with your dotted line and see the trends in the data, or if the data has a natural order, right? And so things like, looking at how much profit a company makes month by month, things like looking at how temperatures change over the course of a week or over the course of a month or a year, right? Those kinds of examples are where a broken line graph are going to be really useful. Or, if you want to, I don't know, predict the cost of books that's going to help you as well. Sometimes, though, a bar graph is going to be useful, right? And so bar graphs are more useful when the data along the horizontal axis, when those things are discrete, right? And so if you, like, let's say you're measuring the temperatures on a given day at different cities in Canada, right? And so that's going to be a situation where a bar graph is going to be useful. Or let's say, you are timing how long it takes a runner to do a 5K run. That's going to be, and let's say you have 7 or 8 different runners. That's going to be a time when a bar graph is useful. Okay, so you have to look at the question, look at the data set, and figure out if the data is continuous, or if you're looking at trends, then a broken line graph. If they are independent or they're discrete bits of data on the horizontal graph or horizontal line, then a bar graph is going to be better. Okay, so here's a situation where there's a broken line graph for each data set. So here are the days of the week in order, and then the bottom one is the temperature. It's ranked from lowest to highest. It's increasing order. Okay, and so you want to start considering which graph gives you the most information, and then what actual trend do you see. And so I'm going to kind of flip back and forth because I have a couple graphs set up. They are not the neatest, but I'm going to try and post them out. Okay, so I have this graph with all the days in order, and I have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I got enough. Okay, so I'm going to go just by ones. So here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then just for fun, here's 14. So now I'm going to go back to my graph over here, and on Sunday the temperature was 12 degrees, so I go back over here, and then on Sunday, here's 12 degrees. Okay, Monday is 7, Tuesday is 10. Monday is 7, Tuesday is 10. I'm lining my stuff up. Wednesday is 8, Thursday is 6. Wednesday is 8, Thursday is 6. Friday 7, Saturday is 5. Friday is 7 and Saturday is 5. Now, what I can do, I can use my dashed line and keep drawing. Now, I think, I will undo that for a quick sec and make sure that I get my dashed line again. Aha! So that's Sunday to Monday, Monday to Tuesday, Tuesday to Wednesday, Wednesday to Thursday, Thursday to Friday, and Friday to Saturday. And so you can sort of look at this bit of data and start making some judgments about the overall trend. The other one asks us, it looks at it this way. This is ranked, right? And so I have it set here, so I have 5 and 6. Okay, so again, 1, 2, 4, 6. I'm not running out of time here. 8, 10, 12, 14. And again, it was 5 and 6. 5, and then 6. 7, 7, 8. The last two are 10 and 12. And so here's 10, and this is 12. Now I'll go back to my dotted line. Love 'em. And I'll just start joining the dots. And what the overall question was on this first slide here was, what graph gives you the most information? The first one, obviously. The additional information that the first graph shows us is that the temperature decreases sort of from Tuesday to Saturday. There's a decreasing temperature trend. This one makes it look like the temperature is increasing throughout the week, even though these days like Saturday, Thursday, Monday, Friday, Wednesday, Tuesday, Sunday are completely out of order, right? And so that's a way you can mess with the data, although a close observer will not see that stuff, or will see that stuff. And so I encourage you to make sure that this stuff is done closely, that you look carefully at the data, and make sure that you can make correct predictions. Okay? Because there is a question, there's actually a bonus question on page 50 that kind of looks at this idea about making a company look like it's making a lot of money. So just pay close attention to that. There's also questions where you need to consider whether a broken line graph or a bar graph is more appropriate. So I think that's all the data you really need to do this stuff. So I'll stop the video here. Have a great day, and I'll talk to you guys soon.